Welcome everyone to Cassandra Lunch number 43. We are less than 10 away from a full year's worth of Cassandra Lunches. So for today's Cassandra Lunch, the topic is going to be on DSBulk and how we can use it with tools like Sed and Awk to do Cassandra data operations very efficiently. And I will be giving the presentation. I'm a junior engineer here at Anant. Currently, the only organizer for this event is Rahul. We are looking for co-organizers who essentially spread the word about the event, find people who want to talk, and then look out for if there's any organization or institutional sponsors that want to help sponsor us. If you are interested in that, you can reach out to rahul@anant.us. We are part of Data Community DC, and Data Community DC believes in building diverse communities, no matter their race, gender, sexual orientation, religion, et cetera, et cetera. So we are a very inclusive organization, and we hope to have everyone feel that way. All right, and Data Community DC is made up of a bunch of different organizations. Data Community DC, Data Visualization, Data Wranglers DC, which is also where we host our data engineers lunches on Mondays. If you want to come out to those as well, and you can find out more about Data Community DC at datacommunitydc.org, and you can find out upcoming events at events.datacommunitydc.org. So what do we cover here? We essentially cover the Cassandra protocol. So how do nodes talk to each other? How can we efficiently do Cassandra operations? And so generally we cover Apache, open source Apache Cassandra, DataStax Astra, and then we also have looked into other tools that also are Cassandra compliant. So like Scala, Yugabyte, Cosmos DB on Azure, Amazon Key Spaces. Yeah, and so we talk anything that talks Cassandra. This is the portion where we generally open up the floor to anyone new. I'm looking through the participants. So essentially anyone new to this event, what to talk about, what they do with Cassandra, what they hope to get out of this, and what they could potentially present on. So I think I see two new names. So Javid, do you want to say hi?
Hi team, this is Javid. I recently joined Anant. Can you hear me?
Yeah, we can hear you.
Yeah, thank you.
And then Eric, I believe, I'm not sure. I think this might be your first time.
Yeah, this is my first lunch. I'm Eric Probst. I work for Vital Images. We do healthcare software, and our underlying database is Cassandra, and I work in professional services and deployments. So sometimes I need to use tools like DSBulk to help customers with particular issues.
Great. All right, move on to the next slide. And group rules, if you have a question, ask it, because we are a community. But generally, try to be polite and courteous to others. And as I mentioned, because we are a community, please do share what you know with the rest of us, because the more you know, the more everyone will know. And generally, depending on who's speaking, they might have a little preference in how questions are asked. So generally, you can ask your questions to the chat, and then the speaker can find a good time to stop and look and potentially answer any questions. But for me personally, today, if you have any questions, just go ahead and speak up. You can put them in the chat. I can also find them at a good stopping point. But generally, if I miss something or you have more to add to what I'm saying, feel free. All right. And then we are not, we help companies build global real-time data platforms, data analytics platforms. DataStax is a sponsor and partner. GW is also a sponsor. They help us do in-person venue space. So hopefully when everyone's vaccines are through and we got the herd immunity, we will be back in person. All right, and these are a couple organizational and institutional sponsors for Cassandra Lunch. And if this portion is, if anyone has any announcements, if anyone's looking for a job, or if anyone's hiring, if anyone has any events that they'd like to essentially advertise, they can go ahead.
I have a quick announcement. So Data Community DC is putting together Data Week DC, and that is basically coming up in September. So, oh no, it's now changed to October. It's new every day, but they are looking for volunteers, you know, to help organize, help whatever. It's a great thing. I've been part of it for a few years. I just don't have the time this year. But they're always looking for folks to get involved, and you meet a lot of really smart people. You get to know all of the other organizers. You know, it's been a lot of fun. But yeah, I'm just not able to contribute this year. But if you're in the DC area, actually probably doesn't even matter. They're looking for people to help out. Yeah, that's it.
All right, and then these are some upcoming Cassandra-oriented events. DataStax has weekly workshops. We have this event every Wednesday at noon Eastern. We also have Data Engineers Lunch, as I mentioned earlier, every Monday at noon Eastern. And a couple upcoming topics we have are Airflow in Cassandra, Kubernetes in Cassandra, and Jenkins in Cassandra. I know, so we've already put out part 1 of the Cassandra on Kubernetes series that Rahul is doing. And part 2 is upcoming whenever he's in line for the next Cassandra Lunch. All right, and you can also find all of these videos from Cassandra Lunch 10 on our YouTube channel, youtube.com/AnantCorp, or you can just Google for Cassandra.Lunch and you should be able to find this playlist. And then also for all the best knowledge on Cassandra, Cassandra.Link is Anant's and curated website where we put together the best knowledge on Cassandra. And if you're looking for something, you can go ahead and search for it. And if you're looking for a job, we also have that as well. All right. That will wrap up the introduction section, and then we move on to the topic for today, which is DSBulk with Sed Awk, and how we can do Cassandra data operations with DSBulk, Sed Awk. Can everyone still continue to see the new slide deck?
Yeah.
Okay. So if you're not familiar with DSBulk or DataStax Bulk Loader is, it's essentially a tool that can be used for loading, unloading, and counting data to or from generally DataStax Astra, DSE 4.7 and more recent, and then open source Apache Cassandra 2.1 and on. So the DSBulk command, once you've downloaded it or whichever distribution you're using, and have set it up to your path. So the command would look like DSBulk and then load, unload, count, etc. And so the subcommands of DSBulk are load, unload, and count. They do have a few required options when you're running your commands. The first one is a key space. So what key space to look at, what table to look at. And then if you want, you can have like a schema query. So you can literally write out a query when you're running a DSBulk command. But generally, from what I've seen, people will generally use it for unloading, loading, and counting. But if you want, you can run just a CQL query using DSBulk. So when you're using DSBulk's load or unload subcommands, they require a designated data source, like a CSV or a JSON. So if you're working with load, it doesn't necessarily mean it has to be a CSV or JSON. So say if you're working with some text file or an STD in, and you're piping it along, as we'll do in the demo portion, but essentially you can pick up data anywhere. And then as long as it's in CSV format, you can still use DSBulk on it. So the standalone tool is launched using the command DSBulk, and from within the bin directory. So again, you would just set your path to whatever the path is, and then the bin, etc. And so generally, it detects any failures due to failed lightweight transaction write operations, which is really nice. And we'll see that when we go into the demo portion. It actually has like a analytics function, or not an analytics, but it's showing you like essentially the number of rows operated on, failures, speed, et cetera, and we'll take a look at that once we get to that portion. And any of these failed records that fail to write usually go to one of three files in the DSBulk folder. So like there's a connector bad file, a mapping bad file, and a load bad file. And what exactly those files are, there's more information. You can click on that link when the slide deck goes up. And all DSBulk options can be passed in the command line itself as an argument, or they can be in a configuration file. And there's a ton of different options that you can have, and a lot of them have shorthand functions. So generally, so like this flag K is shorthand for flag key space, right? So with that connector options document, you can just go through and see what you need. And there's generally a shorthand version for it. So if you look at here on the right, this is generally the syntax of how a DSBulk command looks, just in a very simple form. So you have DSBulk, so the main command, and then one of three subcommands. So say if we're loading into an instance of Cassandra, we would say DSBulk, and then generally we would have a source. So if we're loading from just a flat or like a single CSV file, we would designate it with the flag URL. So essentially telling DSBulk, here is our CSV file that we're using to load into Cassandra. So we'll say DSBulk flag URL, wherever the path to the CSV is, or JSON, whichever one you're using. We would say load, and then any other option, or the option, so K, flag K, then your key space name, flag T, then your table name. And then you can have either you can take that, or actually generally load would probably be at the end of a pipe. Or if you're doing other operations on it, so if you're loading it somewhere, then directly unloading it right after to do multiple table instances all in one command, it could be done. But yeah, so the demo portion is going to be covering, so we could do DSBulk all within the same Cassandra instance. So either on DSC or on Apache Cassandra or on Astra. But I wanted to show you that there's more variability in what potentially you could be doing. So the way I've set up the demo is that we're going to load, like manually load 100,000 records. So that was just the total amount, or like the maximum amount. Sorry, there's a plane going over. So we're going to manually load. There's instructions for it, and I've already done it for time's sake for this demo. This demo probably will only take a short amount of time, but mainly it's just going to be talking through steps. But essentially, the first step would be, if you're doing this on your own, would be to load the CSV file that's in the repo, and I'll share the link. Got it right here. I'll share it in the chat. So essentially, Astra has a data import function, which is really nice, as we can upload CSV data directly in, and it'll create a table for us, and we can pick manually what our primary key or partition keys would be, and what our partition columns would be, and what our clustering columns would be. But essentially, we have already done that, but we'll still discuss it a little bit. And then what we'll do is we'll unload data from Astra using DSBulk locally, and then we'll do some transformations on it with awk and sed, and then we'll write it to its CSV. And then we'll load that new CSV into a Dockerized Apache Cassandra instance using DSBulk. And then we'll truncate it and then do that same process again. But instead of having to write the unload to a CSV file, we'll unload it, do the transformations, and then write it and then load it directly into Docker or the Dockerized Apache Cassandra instance. So that way, I read online, Rahul, you can correct me here, but sometimes it might be better to decouple the event depending on the size of your data. But I think for 100,000 records, it does the job just fine.
Yeah, I mean, DSBulk is not Spark, so it makes sense. And I would never trust it to do like a terabyte of data, maybe like 100 gigabytes. You could try it out, maybe 10 gigabytes. Yeah.
Oh, excuse me. Okay, so yep, let's go ahead and get started. So as I mentioned, so we'll start with DataStax Astra. And can everyone still see my screen?
Yep.
Okay, cool. So you can see that I've already done some playing in this test database, right? So Astra's changed the structure of like the payment methods go before. Like before, you used to be able to get a free tier, just no problem. But nowadays it's a pay as you go, but essentially per database you get $25 worth of credits. And with this, I've done 4.8 million read requests, 1.1 million write requests, and I've only really spent $4 worth of credits. So it's essentially just a free way of getting a free deployed and in the cloud or Apache Cassandra, but DataStax Enterprise database in the cloud. But yeah, so what we'll be doing is, if you're doing this demonstration for the first time, you would essentially, once you create your database in your key space, according to the instructions on the repo, you would go to upload data, and then essentially you would just take this CSV file and then upload it into here. And then when you get to the configure stage, you would just set the UUID or the employee ID column as UUID, and the first day and last day as timestamps, and then you would just load to the target database. So sometimes it doesn't work on the first try, and it might throw an error saying that it failed. But when you're usually it'll work by the second time. So I've like truncated the entire table, dropped the table, and then re-uploaded the same CSV multiple times. But generally it works with 2 tries if it doesn't work on the first. But essentially, let's go back to my database. This will load. Okay, so just going to the CQL console, I'm just going to describe this table. So essentially, we've created, using that CSV, we created a table called previous employees by title. And so essentially, it's 100,000 records of dummy data, but essentially people who've worked in your organization or whatever. And they have a job title, they have an employee ID, they have an employee name, so that's first name and last name, and then they have their first day, and then they have their last day, and then the primary key is with the partition column of job titles, so they're partitioned by their job titles, and then their employee ID is for clustering and additional uniqueness. So essentially, if I just do a select count on it, we have 100,000 rows. So what we'll do with this 100,000 rows is we'll unload it from Astra using DSBulk. We'll use awk to do some data transformations, and then we'll use sed to do some substitutions, and then we'll use DSBulk again to load it into a Dockerized Apache Cassandra instance. So we'll start with the Actually, let me pull this up because I'll just be copy and pasting some commands. Okay, so go ahead and open a terminal. Can everyone still see the terminal?
Yep.
Okay, and then I will zoom in a bit. Okay, so first what we're going to do is just clone the repo down. And then we're going to CD into it. So that way we're working directly out of the directory. So assuming like the next step would be to upload that CSV file into DataStax Astra. And then once you do that, you also need to generate an application token. So they also changed it a little bit there. So we'll need to go to settings, and then you essentially just select an admin user. And then when you generate this token, this client ID will be your username, and this client secret will be your password. So you'll need to, or you can also download it as a CSV, but you'll need to copy and paste this. If you're doing this for the first time by yourself, either just download the CSV of it or just copy and paste it somewhere. So that way you can put it into the DSBulk commands. Okay, so now we will also need to download our Secure Connect bundle. And so you would get that by going to the Connect tab and then just going to any one of the items under driver, and you would just hit download bundle. And then, so everything's ready for Astra, right? So we have our data in, we have our bundle, we have our token, or at least we have our client ID and client secret. So now we can set up our Docker container. And so essentially what we're doing here is we're saying Docker run, create a Cassandra container, Cassandra latest, expose port 9042, and then also mount this working directory. So again, we're saying take our working directory and then put it onto the root for this folder in the Docker container. So once that loads, we're just going to give it a second, because why we're doing that is because within this like repo, we have a CQL file that will generate the table for us. And so essentially we're just doing that so we can load it, and it's not much else to add. So I'm just going to Docker dash. All right, and then if I just do a list example, so we've essentially taken our local directory and put it on it. So then we'll use the CQL terminal, the CQL/sh terminal, and just run a source to run this CQL file. So if I just do I got a CD into it. Days worked. So essentially what we're doing is we're creating a key space of the same name just to make it easier across the board. And then we're creating a table called days worked by previous employees by job title. So we're still keeping job title, we're still keeping employee ID, we're still keeping employee name, but instead of having the first day and last day, we want to calculate the duration that they worked in days. And then we can do that using awk. And then we'll still keep the primary key as job title and employee day. So essentially it would be the same exact table we have in Astra minus the first day and last day columns, but instead we would have a calculated number for the duration of that in days. And so now that we have that set, I'm going to open a new tab, and I'm just going to open up CQL/sh, and then we are going to run the source command. And then so if we just say describe table test.days worked, and so our table is now there. All right, so now we can move on to actually running DSBulk. So what's going to happen in this first command? So I'm just going to copy and paste the. I'm just going to copy and paste the what the command would look like without my actual credentials in it for now. But essentially what we're doing here is we're saying DSBulk unload from the key space test from the table previous employees by title. And again, this is the Astra database because remember, we're unloading from Astra. So this was the table that was generated from the CSV. This flag B is for the Secure Connect bundle. And I forgot a step, so let me open this repo, VS Code. It will load for me. Okay, that's acting up. So I'm just going to quit it. Okay, there we go. So we have our repo, and I'm just going to drag and drop the Secure Connect bundle that I've already downloaded plenty of times. So I just have to rename it. So essentially it's just Secure Connect and then your database name. So whatever you named it in Astra, and then it's a zip. So it's essentially like an off packet. But essentially, because it's in our repo, the DSBulk just uses the relative path on it. Pull this back up. All right, and then we say our username is, remember, our client ID. So when we did that token in Astra, password is the client secret. And then what we're doing here is we're using awk, GNU awk specifically. We're saying our flag capital F. And again, if you haven't really used awk or Sed before, I have given presentations on them. So basic introductions of how to use them for data engineering. So essentially examples similar to this, where you can get a quick idea of how you can use awk for data engineering. So you can use it for Cassandra. Find those videos on our YouTube channel, youtube.com/AnantCorp. And yeah, so this flag capital F is essentially designating the file or the field separator, and we're saying comma, which is the field separator, and we're using lowercase f option to designate that we're running a script. And so our script is called duration calc.awk, and we'll take a look at that in a second. And then so essentially what we're saying is unload the table, pipe it into awk right here. And then once you do that, pipe the output of that into Sed. And then we're doing a quick little Sed replacement. So the header that comes out of awk is not what we want. So we needed to match what we're doing. We needed to match the schema that we created in the Dockerized container, right? So we're saying when the awk script runs, it generates the 0 because we got rid of the fourth and fifth columns, which are first day, last day. And so we need to substitute it with the stuff we actually need. So we substitute that entire pattern as the new column headers, and then we write it to a CSV called days worked by previous employees by job title. So this is the first method, as I mentioned in the introduction part of it. This first method is decoupling the process. So we're taking the load, doing our transformations, writing it to a CSV, and then we'll pick it up using load and then write it into Cassandra. And then we'll do everything all at once. So I will now paste in the version I have with credentials. So it's the same thing, except I just have my database name, and then my username, which is the client ID for one of the tokens I have, and then the password, which is the client secret for one of the tokens. But essentially, when I say this, we'll see that it's picked up the directory it's working out of. And then we'll start seeing the total number of rows, 0 rows failed. We see the operation speed, so how many rows were operated on per second, or how many were unloaded per second, and then just other additional items. But essentially, the entire unload of 100,000 rows from Astra happened in 2 seconds. So if I just do a quick cat on it, what is it called? Days worked. So we see it's very large, but essentially we've kept the job. We have employee ID. We have a full first name, last name as employee name. But then instead of having a first day and a last day, we've calculated the duration of it. And again, because I used like a random data generator, the numbers are a little wonky, but it's essentially the process of doing it is what we're trying to show. But so to look at what the awk script actually does, I'm just going to move this over. So let's look at duration calc. So we'll look at this bottom part first. So what we're doing here is we're saying G sub, take any dashes, colons, in capital T's and substitute it with the white space for field number 4. So essentially field number 4 would be column number 4 because we used a field separator with the capital F comma, and that designates, so that would translate. So the incoming data, column 1 would be field 1, column 2 would be field 2, column 3 would be field 3. And so we know off the bat, first day is column 3 and last day is, or sorry, first day is column 4 and last day is column 5. So because we already know that, we can act and directly adjust data we know and specifically that field. So that was where I was kind of playing with between Sed and awk. So I realized that if I wanted to do the same substitution with Sed, it was just easier to do with awk because you can designate the specific field to look at, right? So if we were using Sed, the way Sed works is it works off a pattern and then it acts on the first per line, the first available of it. So because we have 2 timestamps, we would have to set a global option, but say if we were saying substitute -T, because we're using a UUID for our employee ID, what if that pattern gets matched in there accidentally, right? And so I found that there was more precision with awk, so I chose to use certain substitutions with awk over Sed. But again, this is something that, depending on your scenario, Sed might be better than awk for the substitution. So this is just an example of how you can think through the process and potentially apply it to your own. But once we do that, we also adjust and take the Z out of the time zone. And the reason we're doing this is because we need to format the timestamp that comes back from DataStax Astra. And we need to say year, 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 white space, month, month, white space, day, day, et cetera, et cetera, et cetera, all the way from year to seconds. So every unit of time has to be separated by a white space. So essentially we're just cleaning data using awk. And then we say first day, calculate the time in seconds. Last day, calculate the time in seconds. And then print out the first field, so column 1, field 2, column 2. So it's job title, employee ID, because that's the partition, and then the clustering column. Then we have the employee name. And then what we're doing here for the 4th column is because we're not using 4 and 5 anymore, we're printing out a calculated value per line. So we're saying is do last day minus first day. So that will get you a duration, right? And then divide that by the number of seconds in a day to get you a value in days. And then we round that because the number that comes out of this part is a floating number. So we need to give it a round function, which awk provides, and we just copy and pasted it in. But essentially it rounds correctly, either down or up, depending on the decimal value, and gives you back a nice whole integer. However, when you print this, sometimes you might get back a negative number, right? So because we're using generated test data, the last day might be months or years before the first day, or sorry, the last day could be months or before than the first day. So we have to count and we have to say, just give me the absolute value back, right? Because no matter what the subtraction is, the duration would still be the same between the 2 numbers. So we just say with this conditional, we're saying if the round value that comes back is less than 0, so if it's a negative number, multiply it by -1 to give me the absolute value. Otherwise, just give me the number back. So that's just some conditional like functionality that we can say in awk when we're doing prints. But yeah, so that will then take the incoming data from the unload, do these operations, calculate the duration in days per row for 100,000 rows, and then we do that sed replacement, which updates the header, and then we wrote it into the CSV that we just visualized. So now what we could do is take this CSV and load it into our Apache Cassandra instance on Docker. So what we're saying is DSBulk load URL, because again, we need to point to where our data is. So we're saying URL, whatever CSV we just generated, our key space in the destination. So our key space is still the same. And then we have this table that we created with the CQL file with the source command, right? And that's all we need to do. And when we run this, we'll see the same analytics that we did with the unload, but this time it'll be for the load options. And so you see how it kind of incrementally went up. You may have missed it depending on if there's lag time, but essentially we first saw 86,000, then we saw 100,000. So depending on the size of data you're working with, you can potentially see how it's working incrementally. But again, it still shows us the total of rows operated, if there was a number of failed rows, rows per second. So it essentially wrote 16,000 rows per second, and then it happened in 29 batches, I believe. But essentially the entire load happened in 5 seconds. So now if we go to our terminal that's running CQLSH, and we just run a select count from test, we should get back 100,000, and we do. So we were able to unload data from DataStax Astra, do data transformation. So if I just do a select all from test where job title, because that's our partition column, equals, I think one is like a dentist. Essentially we see our partition, our journey, or our partition column, our clustering column, their full name, and then the days worked, and they're all positive values. So now if we just want to run a truncate on it, and then we just run a select count, just to confirm that there's 0. So now what we'll do is, instead of having that first step that wrote to a CSV, we're just going to pick it up from DataStax Astra, do our transformations, and then directly load it, just so it's 1 pipe, 2 pipe, 3 pipe, 4 pipe. So we'll go ahead and copy this command. And so we're, again, what we're doing here is we're saying DSBulk unload. So this is all still the same. But instead of after the sed substitution, instead of saying output, like a greater than symbol, right to a CSV, we're just saying take the STD out, pipe it into DSBulk, DSBulk load into the same key space, so key space test, and then the same table we're working with. And if we run this, we'll see the logs, and then we should see the analytics in a second.
Should call this DSBulk sorcery. This is awesome. Really cool.
So this happened in about 11 seconds. So now if I go back into Docker, or back into the CQLSH terminal, and I run the select count, we have 100,000 rows again. And if I rerun this dentist one, our rows are still the same. So let's see, 5871, 5871, 5871. So the data is still the same, but again, depending on the size of data you're working with and moving from DSC or Apache Cassandra or Astra, if you're working with, like Rahul said, like terabytes of data, it might be better, or like it might not be the best tool for it in general, but it may be better for you to decouple the process of write to a CSV and then load it after, or you can just take a single command and unload it, do transformations, and then load it into your new destination. But yeah, that wraps it up about for this demo portion. Sorry, I lost my chat window. No one had any questions, but if anyone does, they can go ahead.
Yeah, so the what you just kind of the last thing that you showed is that, you know, you don't really need to even store any files. I wonder, you know, if DSBulk is built in a way to accept streams or standard in, because that's basically what I mean. I thought about it, and like I think I'd done it once, but in terms of outputting a CSV, I mean exporting and importing it, it worked pretty quickly. There are some settings in DSBulk for kind of performance tuning, both on the export and on the unload and the load. Did you play around with that stuff when you were kind of daisy chaining these pipes?
Yeah, so like the initial unload, if you don't provide like either like a next step in the pipe, it just directly outputs a directory file for you. So, and it's split actually. So like if I just run DS, so actually I can just run it real quick. Let me copy this. So I'm just going to copy the first part of the pipe. I can move these things out of the way. And so I kind of had a similar thing where it's like I was able to get the STD in to work for load. Oh, that's what I forgot to do. So this just printed to the terminal, but if I just do a cat list. So right here, so you see, even though it printed to the actually that's the one we created, didn't we? Okay, yeah, so it's all right, nope, sorry. Okay, yeah, that's the one we actually created. I forget at what point I did it, but essentially what happened was when I ran DSBulk unload without having anything else after it, so just as a single command, it split the CSV. So it created a directory, and within that directory there were 4 CSV files.
Yeah.
And they were I assume they were just separated by their partitions. So Stefan, not the logs, just like directly, just when you unload the file, that's just how it was. So if you're not unloading it and then directly STD, like taking the output and putting it somewhere else, if you write it to a CSV destination, it would kind of look as a directory.
Gotcha. Cool. Very cool. Awesome. Well, good presentation. Yeah, go ahead, JB.
Yeah,
you have a question?
Yeah, I just I have one little question. Is there any way when we can use a SS bulk loader or a DS bulk?
Sorry, could you repeat the question again, JB?
When to use SS bulk SS loader or a DS bulk?
Oh, you mean SS table loader?
Yeah, SS table loader. Yeah, sorry.
Yeah, so I think it depends on the format of data you're working with. So DSBulk only really works with JSON and CSV. So when you're working with like SS table loader, you're working with like SS like sorted string files, and I don't think DSBulk loader works with sorted string. So I think that would maybe distinguish which one you're using for which one use case.
Yeah, and so because DSBulk is not coupled, see, SS table loader is coupled to the Cassandra file format. End of story. But DSBulk is for exporting and importing information. So exporting information, you can export it as JSON or CSV if, for example, you wanted to take data from Cassandra to SQL Server, right? Or from Cassandra to PostgreSQL, then you would use DSBulk. It's much better than copy command, which also works. Technically, you could also use Spark, but as you see, DSBulk, you just give it some config information and it spits it out for you, and it does it pretty fast. The other thing you use DSBulk for is basically importing data from some other source. So CSV or JSON coming from, let's say, Mongo, because you're tired of it, and then you need to put it into Cassandra. You can do that. You can also take CSV exports out of SQL Server and put it into Cassandra. And again, you can use Spark for it. You can use copy for it, but Spark is like major domo, big bad hammer. Copy is like a dinky little hammer. DSBulk is kind of somewhere in the middle. Like it's right in the Goldilocks zone for doing a good amount of data processing. And the other, I think, cool part of DSBulk is you didn't do it, but it also works with Graph inside DSE, which is not a part of Astra, which is not a part of open source Cassandra. But let's say you have a lot of data that represent Graph vertices and edges. You can basically use DSBulk to import it, not have to use Gremlin to write that information. So there's a lot of behind the scenes abilities that we didn't get into, where DSBulk it's far and above much more featureful than SS Table Loader.
Okay, what I understand is, just to add your word, this one, what I understand is SS Loader mainly used for if you want to transfer the data across within the Cassandra database. It might be a different stuff. When it comes to DSBulk load, any other database to Cassandra.
Yeah, you can use it for any other database, but you can also use it within Cassandra, right? Because as you can see,
within Cassandra as well. Yeah. Sorry. Yeah. But within the Cassandra, SS Loader,
SS Table Loader.
SS Table Loader will be
fine. Yeah, exactly. Cool.
Hey, and
good job.
Thank you.
Good presentation. Sorry, David, you had a question? Comment?
Oh, can you hear me? Yeah, I was just curious because this is something that had come up, on the Go contract. Remember that one scenario we were looking at? So I'm just curious when you would decide to use DSBulk Loader as opposed to just using, like you say, the big sledgehammer Spark. Like what would be kind of that dividing line, I guess?
Yeah. So Spark SQL can do a count pretty quickly if you have DSE analytics. It works really, really well because of data locality. And if you have Spark SQL as part of DSE analytics, it doesn't make any sense to use anything else. Like you're just as close to the data as possible, and you're good to go. In the other case of like using open source Spark against Cassandra, meaning it's in a separate system, you're going to be reading, then it's kind of like 1/2 dozen 6 in another, because you literally have to pull the data into the other Spark plus count it. And that's what DSBulk is also doing. But there's a point at which DSBulk is going to break, where Spark will always be able to handle more and more and more and more data. DSBulk is not built for that type of, I haven't tested it, but I imagine that it's in the background, breaking up into threads, maybe even using token range queries. It probably has to be in order for it to work so well with larger data sets. But yeah, that's basically it.
Got it.
Yeah. Yeah, and I did look into that after you asked me that question before, and yeah, it seems like people do use it for count, and I realized that it's probably because they just don't have ready access to Spark SQL, and so it's like, well, okay, that makes sense. But still, I think it's a little kludgy, honestly. Like doing an export to do a count, basically.
Right. But in that particular circumstance, they did have access to Spark SQL. So
yeah,
you were right on.
Well, I don't know if it's right or wrong. It's what it is. It's just some people I'm just saying, not me, but some people see one tool as like the go-to end all for everything. But in my experience, having messed around with this stuff, you just have to have the toolkit and use the right tools for the right job. And sometimes the toolkit of existing tools don't work, so you have to like make something new. But that's been kind of far and few between. I think for the most part, you end up finding things online that will get what you need done. Just like the stuff that Obi presented on before with SS Table Loader with Spark. That was just something somebody put together, probably because SS Table Loader was not working fast enough. So they were like, well, let's just read the SS tables in Spark and write them with Spark. And that's always going to be faster. Spark is always going to end up being, it's because it's like a 747, or a 777. It's a huge toolkit of things beyond just ETL. You can do shit like machine learning in there, which again, for ETL, you may not ever have to do. But I like all the tools out there. SS Table Loader, Copy, DSBulk, Spark, the whole Spark ecosystem of connectors. Heck, I think you can even do Kafka Connect, where you do a change data capture from Cassandra. You can basically keep exporting data out of Cassandra into a topic, into a Kafka topic, and then use that topic to do other stuff. So there's like a billion ways to do this stuff. Awesome, good question. Yeah, good work, Arpan. Thanks for stepping in to MC the meeting. I appreciate it, and for giving the presentation. All right, folks, we're at the top of the hour. We'll see you all next week, same time, same place at Cassandra Lunch. Take it easy, folks. See you next week. Bye.
Thanks, guys.